Now here the question is, the line Lx plus my plus n equals 0 intersects the curve ax square plus 2hxy plus by square equals 1 at the points P and Q. The circle on PQ as diameter passes through the origin. Prove that n square a plus b equals L square plus m square. So here we have this curve which is ax square plus 2hxy plus by square equals 1, and then we have this line Lx plus my plus n equals 0. Now these 2 points are P and Q. Now it says the circle on PQ as diameter passes through origin. So we have this circle which is drawn on PQ as diameter and it passes through origin. Now since PQ is a diameter, that means this angle will be 90 degrees. Now we have to find this condition that this angle is 90. Now we know that in all these questions, what we do is we make the curve homogeneous, and we make the curve homogeneous using these 2 equations. Now first we'll take this equation of line which is Lx plus my plus n equals 0, and we can write this as Lx plus my, it is equal to minus n, or simply Lx plus my upon minus n, and it is equal to 1. Now we'll take this equation of curve which is ax square plus 2hxy plus by square equals 1. Now all these 3 terms, they are of degree 2. So we have to make this degree 2 to make it a homogeneous equation. So what we can do is we can simply write this one as 1 square, or we write this as ax square plus 2hxy plus by square, and will be equal to Lx plus my upon minus n whole square. Now we can write this as an square x square plus 2hn square xy plus bn square y square, and will be equal to L square x square plus m square y square plus 2 lm xy. Now we can write this equation as an square minus L square x square plus bn square minus m square y square plus 2hn square minus 2lm xy equals 0. Now we know that a pair of straight lines, they are perpendicular if sum of coefficients of x square and y square is 0. So from here, if this angle is 90 degrees, then the condition that we'll get is an square minus L square plus bn square minus m square, it must be 0, or we can write this as a plus bn square, it should be equal to L square plus m square, and this is what we need to prove in this question. So the only concept of circle that we need here is angle in a semicircle is 90 degrees. Now here the question is, we are given 2 points A and B, and C is a point which divides AB in a constant ratio tan alpha. If AC and CB subtend equal angles at P, prove that equation of locus of P is this circle x square plus y square plus 2ax secant 2 alpha plus a square. Now here we have 2 points lying on an x-axis. This point A, it is minus a comma 0, and the point B is a comma 0, and then we have this point C which divides it in the ratio tan alpha is to 1. Now coordinate of this point C will be mx2 plus nx1 upon m plus n. So there will be a tan alpha minus 1 upon tan alpha plus 1 comma 0, and then we have this point P such that AC and CB, they subtend equal angles at P. So AC and CB, they subtend equal angles, And we have to find locus of P. Now, if they subtend equal angles, that means this PC, it is an angle bisector. Now, since it is a locus question, we'll assume this P to be H comma K. So we'll let P as H comma K. Now we know the angle bisector property that PA upon PB will be equal to AC upon BC, and AC upon BC is actually tan alpha. So we can simply write PA is equal to PB into tan alpha. Now distance of P from A is this under root of H plus A whole square plus K square, and this is equal to tan alpha under root of H minus A whole square plus K square. Now we can square it. Then we can write this as H square plus A square plus 2HA plus K square, and it will be equal to H square plus A square minus 2AH plus K square into tan square alpha. Now what we'll do is, we'll take everything on the left hand side and we'll take H square, A square and K square together. So it will be this H square plus K square plus A square into 1 minus tan square alpha plus 2AH 1 plus tan square alpha, and it will be equal to 0. Now we'll divide everything with 1 minus tan square alpha. So we can write this as H square plus K square plus A square plus 2AH 1 plus tan square alpha upon 1 minus tan square alpha, and it will be equal to 0. Now 1 minus tan square theta upon 1 plus tan square theta is cos 2 theta. So this expression is secant 2 theta, which in this case is secant 2 alpha. So we can write this equation as H square plus K square plus A square plus 2AH secant 2 alpha equals to 0. And in the end, we'll replace H and K with X and Y. So this equation, it will be X square plus Y square plus 2AX secant 2 alpha plus A square equals 0, which is what we need to prove in this question. Now here the question is, a circle is drawn with its center on the line x plus y equals 2 to touch this line 4x minus 3y plus 4 equals 0 and pass through the point 0, 1. Find its equation. Now let the center be h, k, and since the center it lies on this line, we can write h plus k equals 2 or simply k equals 2 minus h. So we'll write this center as h, 2 minus h. Now this circle, it touches this line, and we know that condition of tangency is perpendicular distance from the center must be equal to its radius. So if we write perpendicular distance from the center to this line, it will be this 4h minus 3 into 2 minus h plus 4 upon under root of 4 square plus 3 square, and it will be equal to its radius, and we can write this radius in terms of this distance of center from this point on the circle. So it will be this under root of h square plus, now 2 minus h minus 1 will be 1 minus h whole square. Now this is simply 7h minus 2, and it will be equal to this 5 into under root of 2h square minus 2h plus 1. Now we square it, we can write this as 49h square plus 4 minus 28h, and that will be 25 into 2, 50. So it is 50h square minus 50h plus 25. Now it will be this h square, now minus 50 plus 28. That will be minus 22h plus 21 equals 0. So we can factorize this as h minus 1 into h minus 21 equals 0. So value of h is either 1 or it is 21. Now once we have this h, we can write center of this circle. Now center of this circle will be h comma 2 minus h. So if h is 1, it will be 1 comma 1, or when h is 21, it will be 2 minus 21, which is minus 19. And we can also write its radius. Now this r is under root of h square plus 1 minus h whole square. Now if h is 1, then this radius is 1. And if h is 21, it will be this 21 square plus 20 square, which is under root of 841. Now once we have center and radius, we can write equation of this circle. So equation of this circle will be either x minus 1 square plus y minus 1 whole square, it is equal to 1, or it will be x minus 21 square plus y plus 19 whole square, and that will be equal to 841. And this is the answer to this question. Now here the question is, a point moving around this circle with center at -4, -2 and radius 5 broke away from it either at the point A or point B on the circle and moved along a tangent to the circle, passing through the point this D 3, -3. Now we know that a moving point on a circle will go along its tangent, and since it says if it either goes from A or from B, it goes through the same point D. That means we are talking about pair of tangents drawn to this circle from this point D. So we have this circle with center at -4, -2, and then we have drawn two tangents at these points A and B, and these tangents, they pass through this point D, which is 3, -3. Center is at -4, -2. And that's your radius, which is 5 units. Now the first question is, find the equation of tangents at A and B. Now what we'll do is, we'll write equation of tangent to this circle in terms of slope of tangent. So we can write this as y plus 2 equals m, and x is x plus 4 plus minus r, and r in this case is 5 under root of 1 plus m square. Now here we are looking for the tangents which pass through the point D 3, -3. So we'll put y as -3 and x as +3. So now it will be this -1, and then this is 7m plus 5 under root of 1 plus m square. We can also write this as plus minus 5 under root of 1 plus m square, and it will be equal to -1 minus 7m. Now we square it, we can write 25 plus 25m square, and it will be equal to 1 plus 49m square plus 14m. Now 49m square minus 25m square is 24. So that will be 24m square plus 14m minus 24 equals 0, or 12m square plus 7m minus 12 equals 0. Now we can write this as 12m square plus 16m minus 9m minus 12 equals 0, or it will be this 4m, and there will be 3m plus 4, and then minus 3, and this is 3m plus 4 equals 0. So value of m will be either 3 by 4 or value of m is minus 4 by 3. And as we can see, product of slope is -1. That means this angle, it is 90 degrees. Now once we have m and we have this point, we can write equation of these tangents. So one of the equation will be y plus 3 equals 3 by 4 x minus 3, which is 3x minus 4y, and this is 12 minus 9 minus 21 equals 0, and the other one will be y plus 3 equals minus 4 by 3 x minus 3, which is 4x plus 3y minus 3 equals 0. So these are the equation of two tangents. Now the second question is find the coordinates of the points A and B. Now once we have equation of tangents and we know the center, which is minus 4 comma minus 2, we know that these point of contacts are basically foot of perpendicular. So we'll use this foot of perpendicular formula to find the coordinates of these points A and B. So for this second part, first we're going to start with this line, which is 3x minus 4y minus 21 equals 0, and we'll find foot of perpendicular from center, which is minus 4 minus 2. Now this is x plus 4 upon 3 y plus 2 upon minus 4, and will be this minus, and then this is minus 12 plus 8 minus 21 upon 3 square plus 4 square. So it will be this x plus 4 upon 3 y plus 2 upon minus 4, and here this is 25 upon 25, which is 1. Now value of x is minus 1 and this is minus 6. So one of the point of contacts, say this point A, it is minus 1 minus 6. And now we'll take this other equation, which is 4x plus 3y minus 3 equals 0, and now we'll find foot of perpendicular from center. So it will be this x plus 4 upon 4 equals y plus 2 upon 3, and will be equal to this minus, and this is minus 16 minus 6 minus 3 upon 3 square plus 4 square, which again is 1. Now in this case, value of x is 0 and value of y is 1. So this other point is 0 comma 1. So coordinate of these points of contact, they are minus 1 comma minus 6 and 0 comma 1. Now this third question is we need to find this angle ADB and the minimum and maximum distance of D from the circle. Now as we have already seen that this slope is 3 by 4 and this slope is minus 4 by 3. Product of slope is minus 1. So basically this angle, it is 90 degrees. So we can simply write angle ADB, it is 90 degrees. And now we have to find minimum and maximum distance of this point D from the circle. Now what we'll do is we'll find distance of this point from center. So it will be the CD. So we'll write CD, and that will be equal to under root of, now this is 3 minus of minus 4, 7. So it will be this 7 square plus, and this is minus 3 plus 2, 1, which is under root 50, and under root 50 is 5 root 2. Now this point, it is nearest to D, and this other end of diameter will be this farthest point. So this minimum distance will be simply CD minus this radius R. So it will be this 5 root 2 minus 5, and this maximum distance will be this CD plus R, and which is 5 root 2 plus 5. So this is how we find minimum and maximum distance of a point from a circle. Now it says we need to find area of quadrilateral ADBC and area of this triangle DAB. Now we already know that this angle is 90 degrees. So this is 45 degrees. And if it is 45, then this AD is 5. And this distance, it is 5 sine 45. So it will be this 5 by root 2 and 5 by root 2. Now first we'll write area of this quadrilateral ADBC. Now this is R into delta S. So basically it will be this AC into AD. Now AC is 5 and AD is also 5. So this area is 25, and we can also write area of this triangle ABD. Now this is half and then AB. Now AB is 2 times 5 by root 2 into this perpendicular distance, and it will also be 5 by root 2. Now this 2 and 2 will cancel. So this is 25 by 2, which is 12.5. So area of this triangle DAB is 12.5 square units. Now finally the fifth part, equation of circle circumscribing this triangle DAB. So equation of circumcircle of this triangle DAB. Now basically this is a standard result. The circumcircle of this triangle DAB will pass through center of the circle. So basically CD is a diameter, and if CD is a diameter, then center of this new circle, say C dash, will be midpoint of CD. So this C dash will be -4 plus 3 upon 2. So that is -1 by 2. And here it is -2 minus 3 upon 2, which is -5 by 2. And its radius will be half the distance CD. And we know that this CD is 5 root 2. So its radius will be 5 by root 2. So equation of this circle will be x plus 1 by 2 square plus y plus 5 by 2 square, and that will be equal to 25 by 2. Now we can write this equation as x square plus x plus 1 by 4 plus y square plus 5y plus 25 by 4, and that will be equal to 25 by 2. Now 25 by 2 minus 25 by 4 is 25 by 4, and minus 1 by 4, that will be 24 by 4, and 24 by 4 is 6. So this equation will be x square plus y square plus x plus 5y minus 6 equals 0. And also we have to find intercept made by this circle on coordinate axis. Now we know that x-axis intercept is 2 times under root g square minus c, and y-axis intercept is twice under root f square minus c. Now this is 2 under root of, now what is g square? Now g in this case is 1 by 2, so there will be 1 by 4 plus 6. Now this is 25 by 4, so it will be simply 5. So value of x-axis intercept is 5, and value of y-axis intercept will be 2 into under root of, now f is 5 by 2, so there will be 25 by 4 plus 6. Now this is 25 plus 24, 49, 7 by 2, so it is 7. So length of x-axis intercept is 5, and length of y-axis intercept is simply 7. And that is the answer to this question. Now here the question is, find the locus of midpoints of the chord of the circle such that the segment intercepted by the chord on the curve subtends a right angle at the origin. The first step is identify the point. So this point is midpoint of chord of a circle. So let this midpoint be P, and it is given by this alpha comma beta. Now we know that if we are given midpoint, then we can write equation of this chord as t equals S1. Now this t will be alpha x plus beta y minus 4, and that will be equal to alpha square plus beta square minus 4. Now this 4 and 4 will cancel. So equation of this chord will be alpha x plus beta y equals alpha square plus beta square, or we can write this as alpha x plus beta y upon alpha square plus beta square. It is equal to 1. Now this chord, it intercepts this segment which subtends a right angle at origin. So what we'll do is we'll find equation of this pair of straight lines, and we get this equation of pair of straight lines by making this curve homogeneous. So we have this curve which is x square minus 2x minus 2y equals 0, and we have to make it a homogeneous curve in degree 2. Now this degree is already 2, here the degree is 1, and here also the degree is 1. So what we'll do is we'll actually write this as x square and then minus 2 x plus y and into 1, and we write this one as alpha x plus beta y upon alpha square plus beta square, and it is equal to 0. Now this is alpha square plus beta square x square, and then minus 2, and this is alpha x square plus beta xy plus alpha xy plus beta y square equals 0. Now since these pair of straight lines, they are perpendicular, that means coefficient of x square plus sum of coefficient of y square, it must be 0. Now coefficient of x square is this term and this term, so it will be this alpha square plus beta square minus 2 alpha and plus coefficient of y square, and coefficient of y square is simply minus 2 beta equals 0, and that's the required locus. Now we'll replace alpha with x and beta with y. So equation of locus of midpoint of the chord of the circle will be this circle, which is x square plus y square minus 2x minus 2y equals 0. And that is the answer to this question. Now here the question is, find the equation of line with gradient 1 such that two circles, they intercept equal length on it. Now since we already know this law, we can write this equation as y equals mx plus c. So this equation will be y equals x plus c, or simply x minus y plus c equals 0. Now what we'll do is, we'll find perpendicular distance of this line from the centers of the two given circle. Now first one is this circle whose center is at origin. So this is say t1, and it will be 0 minus 0 plus c upon root 2. So from the origin, this distance is mod of c by root 2. And then for this other circle whose center is at 5, 7, this distance will be mod of 5 minus 7 plus c upon under root 2, which is simply mod of c minus 2 upon root 2. Now radius of this first circle, it is 2 units, and for this second circle, radius is under root of 25 plus 49 minus 65. Now 65 minus 25 is 40, and 49 minus 40 is 9. So this is 3. So this radius, it is 3. Now these two lengths, they are equal. So basically we'll use Pythagoras theorem and we equate these two lengths. Now for this first one, it will be this 9 minus c minus 2 upon root 2 whole square, and here will be this 4 minus c square by 2. Now we can write this as 18 minus c square minus 4 plus 4c, and that will be 8 minus c square. Now this c square will cancel. Now this is 4c plus 6 equals 0. So value of c is minus 3 by 2. Now if you put this c as minus 3 by 2, we'll get this equation as x minus y minus 3 by 2 equals 0, or simply 2x minus 2y minus 3, it is equal to 0, and that is the answer to this question. Now the question is, find the equation to the circle which is such that the length of tangents to it from the points 1, 0, 2, 0 and 3, 2 are 1 under root 7 and under root 2. Now let the equation be s equals 0, and which is x square plus y square plus 2gx plus 2fy plus c equals 0. Now we know that this distance, it is given by under root s1. So for this first point 1, 0, it will be this 1 plus 2g plus c, that will be equal to 1. For this second point 2, 0, we can write this as 4 plus 4g plus c, and that'll be equal to under root 7 square, which is 7. And this third point will be this 9 plus 4 plus 6g plus 4f plus c, and that'll be equal to 2. Now first we'll solve these two equations. Now this first equation is 2g plus c is 0 and 4g plus c is 7. So value of g is simply 3 by 2, and if g is 3 by 2, value of c is minus 3. And once we have the value of g and c, we can find the value of f. Now this is 9 plus 2, 11 plus 6g, and 6g will be simply 9 plus 4f minus 3 equals 0. 20 minus 3 is 17, 17 by 4. So value of f is minus 17 by 4. Now once we have the value of g, f and c, we can write equation of this circle. So equation of this circle will be x square plus y square plus 2gx, and plus 2gx is simply 3x plus 2fy, and that'll be minus 17y by 2, and plus c, which is minus 3 equals 0, or we can simply write this as 2 x square plus y square plus 6x minus 17y minus 6 equals 0. Now here the question is, tangents are drawn to these concentric circles, x square plus y square equals a square and x square plus y square equals b square. So we have two concentric circles. Radius of this first circle is say a, and radius of the second circle is say b. That says these tangents are perpendicular to each other. We need to show that locus of that point of intersection is a third concentric circle, and we have to find its radius. Now it says we have to find locus of this point P such that tangents drawn from it to the two circles, they are perpendicular. So since this is a locus problem, we'll choose this point to be some alpha beta. Now this distance is a, this is b, and this is origin 0, 0. Now this angle is also 90 degrees, and since it is a rectangle, this is a and this is b. Now this distance will be under root of a square plus b square. So basically this OP, it is fixed and it is under root of a square plus b square. Now OP is under root of alpha square plus beta square, and will be equal to under root of a square plus b square. So this locus will be alpha square plus beta square, and will be equal to a square plus b square. Now we'll replace alpha with x and beta with y. So equation of this circle will be x square plus y square equals a square plus b square, which again is this third concentric circle whose radius is under root of a square plus b square. Now here the question is, consider circle S with center at the origin and radius 4. Four circles A, B, C, D, each with the radius unity and centers minus 3, 0, minus 1, 0, 1, 0 and 3, 0 are drawn. A chord PQ of the circle S, it touches the circle B and passes through center of circle C. If the length of this chord can be expressed as under root x, find x. So basically first we have the two axes, x-axis and y-axis, and then we have this circle S with center at origin and radius 4, and then we have these four smaller circles, each of radius 1 unit. So that's your origin, and this point is 4, 0, this is minus 4, 0, and these centers are at minus 3, minus 1, 1 and 3. Now suppose this is A, B, C and D. Now it says there is a chord PQ of the circle S which touches this circle B and passes through center of this circle C. So we have this chord PQ which touches this circle B and passes through center of this circle C, and this center is 1, 0. We have to find length of this chord PQ. Now we'll drop a perpendicular from center. This is 90. Radius of this circle is 1 unit. This distance is 2 units, and let this angle be theta. Then we can simply write sine theta as 1 by 2, or simply theta is pi by 6. So basically tan theta will be 1 by root 3, and slope of this line will be tan pi minus theta, and tan pi minus theta is minus tan theta. So slope of this line is minus 1 by root 3. So once we have slope and this point, we can write equation of this line as y minus 0 equals minus 1 by root 3 x minus 1, or simply we can write x plus root 3y, it is equal to 1. So equation of PQ is x plus root 3y minus 1 equals 0. Now we'll find perpendicular distance from center of the circle S. So this perpendicular distance will be 0 plus 0 minus 1 upon under root of 1 plus root 3 square, which is 1 by 2. So this is say R. So value of OR, it is 1 by 2, and OP is radius of the circle, which is 4. So we can find PR as under root of OP square minus OR square, and which is under root of 16 minus 1 by 4. Now this is 64. 64 minus 1 is 63, which is 3 root 7 by 2. And PQ is basically 2 times PR, which is simply 3 under root 7, or we can simply write this as under root of 63. So we have expressed it as under root x. So basically value of x here is 63. Now here the question is, consider a curve ax square plus 2hxy plus by square equals 1. So we have this curve which is ax square plus 2hxy plus by square equals 1, and a point P which does not lie on this curve, and a line is drawn from this point P intersecting this curve at points Q and R. So we have this point P and a line through P, it intersects the curve at Q and R. That says if the product PQ and PR is independent of the slope of the line, then show that the curve is a circle. So what we'll do is, for this question we'll use parametric equation of this line. So let this point be x1, y1, and let the angle this line makes with positive x-axis be theta. So any general point on this line, we can write this as x minus x1 upon cos theta equals y minus y1 upon sin theta, and it is equal to r, where r is distance from this point. Now suppose distance of Q is r1 and distance of r is r2. Now any general point, we can write this as x1 plus r cos theta and y1 plus r sin theta. Now we are interested in finding the points which lie on this curve. So what we'll do is we'll put the value of x and y in this equation. So it will be this a x1 plus r cos theta square plus 2h x1 plus r cos theta y1 plus r sin theta, and plus b y square is y1 plus r sin theta whole square, and it is equal to 1. Now we'll simplify this equation. So it will be this a x1 square plus r square cos square theta plus 2 x1 r cos theta plus 2h x1 y1 plus x1 r sin theta plus y1 r cos theta plus r square sin theta cos theta plus, here it is y1, b into y1 square plus r square sin square theta plus 2r y1 sin theta equals 1. Now what we'll do is we'll write this as a quadratic equation in r. So we can write this as r square, and here will be this a cos square theta plus 2h sin theta cos theta plus b sin square theta plus, and then we write terms containing r. So there will be this r, and we have 2a cos theta plus 2h x1 sin theta plus 2h y1 cos theta plus 2by1 sin theta, and then this constant term which is a x1 square plus 2h x1 y1 plus b y1 square minus 1 equals 0. Now since this line, it intersects the curve at 2 points, this equation will have two roots, r1 and r2. Now it says the product PQ into PR, it is independent of slope. It is independent of theta. Now basically PQ into PR is R1 into R2, and which is nothing but product of roots. And product of roots is C upon A. So which is AX1 square plus 2H X1 Y1 plus BY1 square minus 1 upon this A cos square theta plus 2H sin theta cos theta plus B sin square theta. Now it has to be independent of theta, and it will be independent of theta if this term it is 0. So basically we'll get h equals 0, and if h equals 0 we'll get a cos square theta plus b sin square theta, and we can eliminate theta if a is equal to b. So if a is equal to b, then cos square theta plus sin square theta will be 1. So then it will be simply ax1 square plus 2h x1 y1 plus b y1 square minus 1 upon a plus b, which is independent of theta. So for this curve, this product PQ into PR, it is independent of the slope if h is 0 and a equals b. Now if h is 0 and a equals b, we can write this equation as a x square plus y square equals 1, which is basically equation of a circle. So this curve, it is a circle. Now the question, this line, it is tangent to this circle s equals to 0 at 1, 1, and if radius of circle is root 13, find the equation of circle. Now there are many ways to solve this question, and one of the ways is we have this circle which touches this straight line at 1, 1, and this line is 2x minus 3y plus 1 equals 0. Now let the center be alpha beta and its radius is root 13. Now we know that perpendicular distance from the center to a tangent is equal to its radius. So we can write mod of 2 alpha minus 3 beta plus 1 upon under root 13 will be equal to simply under root 13, and this is our first equation. Now we know that foot of perpendicular from center on this line is this point 1, 1. So what we'll do is we'll use the formula for foot of perpendicular. So it'll be this alpha minus 1 upon 2 will be equal to beta minus 1 upon minus 3, that is equal to minus and then 2 alpha minus 3 beta plus 1 upon 13. Now 2 alpha plus 3 beta plus 1 upon 13 is plus or minus 1. So basically this will be plus or minus 1. And essentially there will be two such points. So basically we'll have two centers. Now we take this plus sign, then we'll get alpha minus 1 by 2 equals 1 and beta minus 1 by minus 3 equals 1. So in this case, value of alpha is 3 and value of beta is minus 2. So it will be 3 comma minus 2. And if we take this minus sign, then it will be alpha minus 1 equals minus 2. So it will be this minus 1 and here will be this 3 plus 1, 4. So center could be at 3 comma minus 2 or at minus 1 comma 4. Now once we have center and radius, we can write equation to this circle. So it will be this x minus 3 whole square plus y plus 2 whole square, and that will be equal to 13, or it will be x plus 1 whole square plus y minus 4 whole square equals 13. So that's one way of solving the question. Another way is, slope of this line is 2 by 3. Means slope of this line will be minus 3 by 2, and this slope will be beta minus 1 upon alpha minus 1, and this is minus 3 by 2. So we get 2 beta minus 2 equals minus 3 alpha plus 3, or basically we can write beta equals 5 minus 3 alpha by 2. So we have this center as alpha comma 5 minus 3 alpha by 2. Now we know that point on the circle is 1, 1 and radius is under root 13. So we can write alpha minus 1 whole square plus beta minus 1, and that will be 5 minus 3 alpha by 2 minus 1 whole square, and it will be equal to 13. Now this is alpha minus 1 whole square, and here it will be this 5 minus 2, 3, there will be 9 by 4 alpha minus 1 whole square, and that will be equal to 13. So basically we'll get alpha minus 1 whole square as 4. So alpha minus 1 will be plus or minus 2. So we'll get alpha as either plus 3 or alpha as minus 1. Now if alpha is 3, then center will be 3 comma 9 minus 5, 4 minus 2. And if alpha is minus 1, then it will be minus 1, and then 8 by 2 is 4. So again we have center and radius. We can write equation to this circle. Another method that we can use is system of circles. So this point is 1, 1. We can write equation of family of circles touching this line at this point. So it will be given by this point circle, which is x minus 1 square plus y minus 1 square plus lambda, and L equation of this line is 2x minus 3y plus 1 equals 0. So it will be this 2x minus 3y plus 1 equals 0. So it will be this x square plus y square minus 2x minus 2y plus 2 plus 2 lambda x minus 3 lambda y plus lambda equals 0. So this equation will be x square plus y square plus 2 lambda minus 1x minus 3 lambda plus 2y plus lambda plus 2 equals 0. Now center of this circle will be at 1 minus lambda and 3 lambda plus 2 by 2, and its radius will be under root of 1 minus lambda square plus 3 lambda plus 2 upon 2 whole square minus c, and minus c is minus lambda plus 2, and that will be equal to under root 13. Now we square it, we can write this as 4 lambda square plus 1 minus 2 lambda plus 9 lambda square plus 4 12 lambda minus 4 lambda minus 8 4 into 13. Now this is 13 lambda square. Now this is minus 8 minus 4, 12 lambda, lambda will cancel and constant term will also cancel. So that will be equal to 4 into 13. Now this 13 will cancel. So value of lambda is either plus 2 or minus 2. So we have two values of lambda, plus 2 and minus 2. Now if we take lambda as plus 2, then we can write this equation as x square plus y square plus 2x minus 8y plus 4 equals 0, and here the center will be minus 1 comma 4, and if we take lambda is minus 2, then this equation will be x square plus y square minus 6x plus 4y equals 0, in which case center is 3 comma minus 2. So these are the three ways to solve this question. Now the question is, find the equation of circle which passes through the point 1 comma 1 and which touches this given circle at the point 2 comma 3 on it. So we have this circle whose center is at minus 2 comma 3 and whose radius is under root of 4 plus 9 plus 3, which is 4. And if we look at this point 1 comma 1, then S1 will be 1 plus 1 plus 4 minus 6 minus 3, which is less than 0. So basically this 1 comma 1, it lies inside of this circle. So this other circle, it will touch this given circle internally at this point 2 comma 3, and it passes through 1 comma 1. Now again, there are many ways to solve this question. So what we'll do is we'll find equation of this tangent to the circle at 2 comma 3. Now as we can see, y coordinate is same for these 2 points. So if we join them, that means this is a line parallel to x-axis. So this line will be y equals 3, and here this line will be parallel to y-axis. So center of the circle will lie at some h comma 3. Now we have to find the value of h. Now these two distances, they'll be equal, so we can simply write h minus 2 square plus 0 square will be equal to h minus 1 square plus 4. So this is h square plus 4 minus 4h, and will be h square plus 1 minus 2h plus 4. Now this h square will cancel, so we'll get this as 2h equals minus 1. So value of h is minus 1 by 2. So center of this circle will be at minus 1 by 2 comma 3, and its radius will be simply mod of h minus 2. So it is mod of minus 1 by 2 minus 2, which is 5 by 2. So equation of this circle will be x plus 1 by 2 whole square plus y minus 3 whole square, that is equal to 25 by 4. And if we simplify this, we can write this as x square plus y square plus x minus 6y. Now this is 1 by 4, 24 by 4 is 6, and this is 9 minus 6 is 3. So equation of this circle is x square plus y square plus x minus 6y plus 3 equals 0. Now here the question is, let the circle be given by 2x x minus a plus y 2y plus b equals 0. Find the conditions on a and b if two chords each bisected by x-axis can be drawn to the circle from the point a comma b by 2. So we have this circle whose equation is 2x square plus 2y square minus 2ax minus by equals 0, and we also have this point a comma b by 2 which lies on the circle. Now it says through this point two chords can be drawn on this circle which are bisected by x-axis. So suppose this is your x-axis, and we have to find the condition that two such chords are possible. Now suppose this point is h comma k, then its midpoint will be h plus a by 2 and then k plus b by 2, and if it lies on x-axis then basically y coordinate it should be 0. So that means value of k is minus b by 2. So this point will be given by h comma minus b by 2. Now this point will lie on this circle, so we can write 2h square plus 2 b square by 4 minus 2ah plus b square by 2 equals 0. Now this is 2 and is b by 2, so we'll get this as 2h square minus 2ah plus b square equals 0. Now the condition is there should be two such chords. That means we should have two distinct values of h. So this quadratic equation in h must have two distinct roots, and it has two distinct roots if d is strictly greater than 0. So we have 4a square minus 8b square greater than 0, or the condition is a square must be greater than 2 times b square. And that is the answer to this question. Now the question is, show that the equation of a straight line meeting this circle in 2 points at equal distances d from the point x1 y1 on its circumference is x1 plus y1 minus a square plus d square by 2. So we have this circle whose center is at origin and radius is a, and we have this straight line which meets the circle at 2 points, say a and b, at equal distance d from point x1 y1. So we have this point, say p, which is x1 y1 and it is at an equal distance. So this is an isosceles triangle. Now we draw a perpendicular. This is 90. And this is also isosceles. So origin will have this perpendicular. Now basically this line will be parallel to tangent at this point P. And we know that equation of tangent at this point P is given by P equals 0, which is simply x1 plus y1 minus a square equals 0. Now a line parallel to this given line will be given by x1 plus y1 plus lambda equals 0. Now we need to find the value of lambda. Now this angle is theta. This angle will be 2 theta. Now this distance AC, it can be written as this d sine theta, and it can also be expressed as this a sine 2 theta. Now sine 2 theta is 2 sine theta into cos theta. Now sine theta will cancel. So from here we can write cos theta as d upon 2a. So this perpendicular distance PC, it will be d cos theta, which is simply d square by 2a. Now we have two things to consider. First, this line, it should be a chord, and it will be chord if perpendicular distance from origin it is less than its radius. So that means this mod of lambda upon under root of x square plus y square will be less than a. This is x1 square plus y1 square, which is a. So basically mod of lambda should be less than a square, and then perpendicular distance from P, it should be equal to this d square by 2a. So it will be this x1 square plus y1 square plus lambda upon under root of x1 square plus y1 square mod will be equal to d square by 2a. Now this is a and a will cancel. This is a square. So value of lambda is plus minus d square by 2 minus a square. So either the value of lambda is d square by 2 minus a square, or it is minus d square by 2 and minus a square. Now in this case, this mod of lambda, it won't be less than a square. So we are going to discard this case. So the value of lambda we'll get is lambda equals d square by 2 minus a square. So equation of this line will be x1 plus y1 plus lambda, which is d square by 2 minus a square equals 0, which is what we need to prove in this question. Now the next question is, the radical axis of the circles touches this other circle, then show that either G is 3 by 4 or F is 2. So first we'll find radical axis of the two circles, and we know that equation of radical axis is given by S1 minus S2 equals 0, where S1 and S2 are equation of these two circles in general form. So S1 is x square plus y square plus 2gx plus 2fy plus c, and then minus, and the other one is x square plus y square plus 3x by 2 plus 4y plus c equals 0. Now here x square plus y square and this c will cancel. So we'll get this as 2g minus 3 by 2x plus 2f minus 4y, it is equal to 0. Now the question says, this line, it touches this circle. Now center of this circle is at minus 1, 1 and its radius is 1 unit. So if we draw this circle, it will touch x-axis and y-axis. So basically, from the origin, the two lines which are tangent to the circle are x-axis and y-axis. Now for x-axis, equation is y equals 0. In that case, this coefficient, it should be 0. So either it will be either 2g minus 3 by 2, it must be 0, or it should be this y-axis, that is x equals 0, where we'll have 2f minus 4 equals to 0. That means either this g, it must be 3 by 4, or f must be 2. And this is what we need to prove in this question. Now here the question is, we need to find the equation of a circle through the point of intersection of two given circles and cutting this third circle orthogonally. Now what we'll do is, first we'll find equation of family of circles passing through point of intersection of two given circles, and we know that this equation is given by S1 plus lambda, S2 equals 0, so it will be this x square plus y square minus 4x minus 6y minus 12 plus lambda x square plus y square plus 6x plus 4y minus 12 equals 0. So we can write this as 1 plus lambda x square, 1 plus lambda y square, and then plus 6 lambda minus 4x plus 4 lambda minus 6y, and then minus 12, 1 plus lambda equals 0, or we can write this as x square plus y square plus 2 into 3 lambda minus 2 upon lambda plus 1x plus 2 into 2 lambda minus 3 upon lambda plus 1y and minus 12 equals 0. Now this circle, it is orthogonal to this other circle, which is x square plus y square minus 2x minus 4 equals 0. Now for this circle, G1 is 3 lambda minus 2 upon lambda plus 1. F1 is 2 lambda minus 3 upon lambda plus 1. And C1 is minus 12. And for the second circle, G2 is minus 1. F2 is 0. And C2 is minus 4. Now we know that condition of orthogonality is 2 G1 G2 plus F1 F2. It must be equal to C1 plus C2. So it will be 2 and G1 G2 is 3 lambda minus 2 upon lambda plus 1 into minus 1, and this F1 F2 it is 0, and this is equal to C1 plus C2, which is minus 16. Now this minus and minus will cancel and it will be this 8. So we can write this as 3 lambda minus 2 will be equal to 8 lambda plus 8. From here we'll get the value of lambda as minus 2. And if we put the value of lambda in this equation, we'll get equation of the circle. So it will be this x square plus y square, and here will be this minus 6 minus 2 minus 8 minus 16 and minus 16 upon minus 1. So it will be this 16x, and here will be this minus 4 minus 3 and then into 2 upon minus 1. So that will be 14y minus 12 equals 0. And that is the answer to this question. Now here the question is, center of the circle S equals 0 lie on the line 2x minus 2y plus 9 equals 0, and it cuts orthogonally the given circle. Show that the circle S equal to 0 passes through two fixed points and find their coordinates. Now suppose this equation S equals 0, it is given by x square plus y square plus 2gx plus 2fy plus c equals 0, and center of this circle is at minus g minus f. Now it says center lies on this line. So we get minus 2g plus 2f plus 9 equals to 0, or we can write 2g equals 2f plus 9. Now we are given another condition, and which is this circle, it intersects this other circle x square plus y square minus 4 equals 0 orthogonally. Now for this circle, G1 is 0, F1 is 0 and C1 is minus 4. Now we know that condition of orthogonality is 2G1 plus F1, it is equal to C plus C1. Now this is 0 plus 0 and this is C, and value of C1 is minus 4. So from here we can write C as 4. So what we'll do is we'll put the value of C and we'll put the value of 2G. So we can write this as x square plus y square plus, and this is 2f plus 9x plus 2fi plus 4 equals to 0. Now what we'll do is we'll take these terms containing 2f together. So we can write this as x square plus y square plus 9x plus 4 plus 2f x plus y equals 0. Now this 2f, it is a parameter. So this actually is some equation s plus lambda L equals to 0, where s is equation of this circle and L is equation of this line, and this family of circle will always pass through point of intersection of this circle and this line. So the fixed points are intersection of these two curves. So basically we have to find point of intersection of this circle and this line. Equation of circle is x square plus y square plus 9x plus 4 equals 0, and equation of line is x plus y equals 0. What we'll do is we'll put y as minus x, then we'll get this as 2x square plus 9x plus 4 equals 0, or 2x square plus 8x plus x plus 4 equals 0. So from here we can write 2x plus 1 into x plus 4 equals to 0. So value of x is either minus 1 by 2 or value of x is minus 4. Now y is simply minus x. So if x is minus 1 by 2, then y is simply plus 1 by 2. And if x is minus 4, value of y is plus 4. So the 2 points of intersection are minus 1 by 2, 1 by 2, and minus 4 and plus 4. And that is the answer to this question. Now here the question is, find the equation of a circle whose radius is 3 and which touches this circle internally at the point minus 1, minus 1. Now center of this circle is at 2, 3, and its radius will be under root of 4 plus 9 plus 12, which is 5. So we have this circle with center at 2, 3 and radius equals 5. And we need to find equation of this circle whose radius is 3 and which touches this circle at minus 1, minus 1. So this is minus 1, minus 1. Now let the center be C dash. Now we have to find center of this circle. So this point is minus 1, minus 1, and say this is P. And this is center of the circle, which is at 2, 3. Radius is 5. And center of this other circle, it is C dash. And its radius is 3 units. So this distance is 2 units. So basically this C dash, it divides it in the ratio 3:2. So center C dash will be given by this 3 into 2 minus 2 upon 5 and 3 into 3 minus 2 upon 5. So it will be 4 by 5 and 7 by 5. And once we have center and radius, we can write its equation as x minus 4 by 5 square plus y minus 7 by 5 square, and will be equal to 3 square, and that is the answer to this question. Now here the question is, find the equation of circle passing through origin if the line pair xy minus 3x plus 2y minus 6 equals to 0 is orthogonal to it. Now line orthogonal to a circle is basically its normal, and these lines, they'll pass through center of the circle. So basically point of intersection of this pair of lines will give us center of this circle. Now we can write this as x y minus 3 plus 2 y minus 3 equals 0, or x plus 2 y minus 3 equals 0, that is value of x is minus 2 and value of y is 3. So center of this circle is at minus 2, 3. And this circle, it passes through origin, that means value of c is 0. So this equation will be x square plus y square plus 2gx. So there will be plus 4x plus 2fy minus 6y equals 0. Now these two circles, they intersect orthogonally. So that means 2 g1 g2. Now g1 in this case is 2 and g2 is minus k by 2 plus f1 f2, and f1 is minus 3 and f2 is k, and it is equal to c1 plus c2. So c1 is 0 and c2 is minus 8. So here this 2 and 2 will cancel. This is minus 8k equals minus 8, that is the value of k is 1. So in this case, value of k is 1, and that is the answer to this question. Now here the question is, show that the locus of centers of the circle which cuts two given circles orthogonally is a straight line, and hence deduce the locus of center of circles which cuts the three circles orthogonally, and interpret the locus. Now let the center of the circle be minus G minus F. And suppose constant term in the equation be C. Now it is orthogonal to two circles, say given by parameters G1 F1 C1 and G2 F2 C2. Now if these first two set of circles they are orthogonal, then we'll get 2 G1 plus F1 will be equal to C plus C1, and orthogonality for these two will be 2 G2 plus F2 and will be C plus C2. Now here we'll eliminate this C by subtracting, so we'll get 2G G1 minus G2 plus 2F F1 minus F2 and will be equal to C1 minus C2. Now we have to find this locus. Now if it is locus problem, we write minus G as alpha and minus F as beta. So we'll get 2 G1 minus G2 alpha plus 2 F1 minus F2 beta, and here we'll get this as minus C1 minus C2. So it will be plus C1 minus C2 equals 0. So this locus will be 2 G1 minus G2x plus 2 F1 minus F2y plus C1 minus C2 equals to 0, which is nothing but equation of a radical axis of these two circles. So essentially, locus of center of a circle which intersects two given circle orthogonally will be their radical axis. Now using the same result, we can find locus of centers of circles which cuts these two circles orthogonally. So basically we have to find their radical axis. Now radical axis is given by S1 minus S2 equals 0. So here x square plus y square will cancel. So we get 4x minus of minus 5x. So there will be this 9x and then minus 6y minus 4y minus 10y and then 9 minus 2 is 7. So it will be this 9x minus 10y plus 7 equals 0. And the interpretation is that this locus is radical axis of the two circles. Now here the question is, a variable circle passes through the point A and touches the x-axis. Show that the locus of other end of diameter through A is x minus a whole square equals 4by, which is a parabola. Now first we'll draw the axis, and then we have this circle which touches x-axis. And it passes through this point A, which is A comma B, and we have to show that locus of other end of diameter. So we have to find locus of this point. Now in locus, first step is identify the point. We have to find locus of this point. So let this point be alpha comma beta, and this is your center, and since it touches x-axis, that means perpendicular distance from the center to this x-axis, it must be equal to its radius. Now we'll find coordinate of the center. Coordinate of the center will be alpha plus a by 2 and beta plus b by 2. Now we'll write radius for the circle, and it will be this 1 by 2 AB, and AB is under root of alpha minus a square plus beta minus b square. Now since this circle it touches x-axis, that means this radius it must be equal to modulus value of its y coordinate, and which is beta plus b by 2. So basically this r will be equal to beta plus b by 2. Now this 2 and 2 it cancel. We square it, we can write alpha minus a square plus beta minus b square, and it will be equal to beta plus b square. Now this is alpha minus a square plus beta square plus b square minus 2b beta, and it will be equal to beta square plus b square plus 2b beta. Now these two, they'll cancel. So we'll get this locus as alpha minus a square equals 4b beta, and in the end we'll replace alpha with x and beta with y. So this locus will be x minus a whole square equals 4by, which is what we need to prove in this question. Now here the question is, consider a family of circles passing through two fixed points and show that the chords in which this circle it cuts the member of the family are concurrent at a point, and we also have to find coordinate of that point. Now what we can do is we can write equation of family of circles passing through these 2 points, and we know that this is given by x minus 3 into x minus 6 plus y minus 7 into y minus 5 plus lambda, and this is x y1, this is 3 7 1 and 6 5 1 equals 0. Now we can write this equation as x square plus y square minus 9x minus 12y, and this is 18 plus 35, 53 plus lambda, and there will be 2x, and then it will be plus 3y minus 15 minus 42, and that will be 27 equals 0. Now we have to find equation of chord of intersection, and we know that it is nothing but radical axis. So we have to find radical axis of two circles. One of the circle is this given circle, and the other circle is x square plus y square minus 4x minus 6y minus 3 equals 0. Now this radical axis will be given by s1 minus s2 equals 0. So now we can write this as minus 5x minus 6y plus 56 plus lambda 2x plus 3y minus 27 equals 0. Now if we look at this equation, it is L1 plus lambda L2 equals to 0, which is family of lines passing through point of intersection of two given lines. So basically all the members in this family will pass through intersection of these two lines. So that fixed point is point of intersection of two lines. So we have to find 5x plus 6y equals 56 and 2x plus 3y equals 27, the point of intersection. So we'll multiply it with 2 and then we'll subtract it. So it will be this 4x plus 6y 54, and if we subtract this second from first, we'll get x equals 2, and if we put x as 2, this is 4, 27 minus 4 is 23, so y is 23 by 3. So this fixed point, it is 2 comma 23 by 3, and that is the answer to this question. Now it says find the equation of the circle which passes through this point 1 comma 1 belonging to the system of coaxial circles that are tangent at 2 comma 2 to the locus of point of intersection of mutually perpendicular tangents to this circle. Now we know that for this circle, the locus of point of intersection of mutually perpendicular tangents is basically its director circle. So equation of this director circle will be this x square plus y square equals 8. Now we have to find equation of a circle which passes through the point 1 comma 1 and which touches this circle at 2 comma 2, and this circle is x square plus y square equals 8. Now what we'll do is, we'll find equation of tangent to this circle x square plus y square equals to 8 at this point 2, 2. And we know that this equation is given by t equals 0. So it will be this 2x plus 2y equals 8, or we can simply write x plus y equals 4. Now we have this line and this point. So what we'll do is, we'll first write equation of family of all the circles which touch this line at 2, 2. And we know that this equation is given by x minus 2 square plus y minus 2 square plus lambda L equals 0, where L is equation of this line, which in this case is x plus y minus 4 equals to 0. Now, of all the circles, we need the circle which passes through the point 1, 1. So we put x as 1 and y as 1. So it will be this 1 plus 1, and here will be this lambda, and 1 plus 1 minus 4 equals 0. That means value of lambda is 1. Now if we put lambda as 1, we can write this equation as x square plus y square, and this is minus 4x plus x. So there will be minus 3x, and the same way will be minus 3y, and this is 4 plus 4, 8. 8 minus 4 is 4. So equation of this circle will be x square plus y square minus 3x minus 3y plus 4 equals 0. Now here the question is, find the locus of midpoint of all chords of this circle such that pair of lines joining origin and point of intersection of chords with circle make equal angle with the axis of x. Now first we have this circle whose equation is x square plus y square minus 2x minus 2y equals 0. Now we need to find locus of midpoint of chord of this circle. Since it is a locus problem, first step is identify the point. We have to find locus of midpoint and let this point be alpha beta. Now we know that if we have midpoint of a chord, we can write equation of chord as t equals s1. So this equation will be given by alpha x plus beta y minus 2 x plus alpha by 2 minus 2 y plus beta by 2, and will be equal to alpha square plus beta square minus 2 alpha minus 2 beta. Now here this 2 and 2 will cancel. So we'll get this equation as alpha minus 1x plus beta minus 1y, and it will be equal to alpha square plus beta square minus alpha minus beta. Now what we'll do is, we'll write this as alpha minus 1x plus beta minus 1y upon alpha square plus beta square minus alpha minus beta, and it is equal to 1. Now it says we have to find this locus such that pair of lines joining origin to this point of intersection, they make equal angle with axis of x. That means slope of one line will be plus 1 and the slope of other line will be minus 1. In that case, m1 plus m2, it is equal to 0. And we know that in equation of pair of straight lines, ax square plus 2hxy plus by square, this sum is 0 if h is 0. So basically what we need to do is, we need to find equation of these pair of straight lines, and in that equation we have to put coefficient of xy as 0. In order to find equation of pair of straight lines, we have to make this curve homogeneous. So we are going to write this as x square plus y square. Here degree is already 2. We have to make degree of these two terms as 2. So we can write this as minus 2 x plus y, and we multiply it with 1, and we can write this as alpha minus 1x plus beta minus 1y upon alpha square plus beta square minus alpha minus beta, and it is equal to 0. Now rather than solving this whole equation, what we'll do is, we'll just find terms containing xy and we'll put that coefficient to 0. Now we'll get xy when this x, it gets multiplied with this y, and when this y, it gets multiplied with this x. So the coefficient of xy in this equation will be beta minus 1 plus alpha minus 1 equals 0, or alpha plus beta minus 2 equals 0. So this is the required locus, and in the end we'll replace alpha with x and beta with y. So this required locus will be x plus y minus 2 equals to 0, and that is the answer to this question. Now the question is, we are given equation of this variable circle which depends on k. It says it passes through the same 2 points for every real number k. First question is, find the coordinates of these 2 points. What we'll do is, we'll rewrite this equation, and we'll write this equation as x square plus y square, and then plus y minus 1, and we'll take all the terms containing k together. So it will be this k into x plus y minus 1 equals to 0. Now basically this equation is s plus k, L equals 0, where s is this circle and L is this line. This is equation of family of all circles which pass through intersection of this circle and this line. So all the members in this family, they'll pass through these 2 fixed points which are basically intersection of this circle and line. So equation of this circle is x square plus y square plus y minus 1 equals 0, and equation of this line is x plus y minus 1 equals 0, and we have to find that point of intersection. So what we'll do is, we'll put the value of x. So here will be this y minus 1 whole square plus y square plus y minus 1 equals 0. So it will be this y square minus 2y plus 1 plus y square plus y minus 1 equals 0. Now this minus 1 plus 1 will cancel. So we'll get this as 2y square minus y equals 0. That is, either the value of y is 0 or value of y is 1 by 2. Now we put y as 0, we'll get x as 1. So one of the fixed point is 1, 0, and the other fixed point is when the value of y is 1 by 2. If y is 1 by 2, x is also 1 by 2. So it will be just 1 by 2, 1 by 2. So these are the coordinates of 2 fixed points. Now the second one is minimum value of radius of circle. So the circle with minimum radius will have these 2 points as ends of diameter. So radius of such circle will be given by 1 by 2 into distance between these 2 points. So 1 minus 1 by 2 is 1 by 2. So it will be this 1 by 4 plus 1 by 4, and it is 1 upon 2 root 2. So the minimum value of radius of this circle C is 1 upon 2 root 2. Now here the question is, show that the locus of the point, the tangents from which to the circle x square plus y square minus a square equals to 0 include a constant angle alpha is the given equation. So we have this circle whose center is at origin and radius is a, and we have to find locus of this point P. These tangents, they make this constant angle alpha. So here this angle will be simply alpha by 2. This is A, and suppose this point is h comma k. Now once we have this A and alpha by 2, we can write OP, and OP is basically A cosec alpha by 2. Now we can write this OP as h square plus k square, and it will be equal to A square cosec square alpha by 2. Now we have to write this equation in terms of alpha, not alpha by 2. Now we'll write cosec square alpha as 1 plus cot square alpha. So here will be this h square plus k square minus a square, and will be this a square cot square alpha by 2. Or we can write tan square alpha by 2 as a square upon h square plus k square minus a square, or simply tan alpha by 2 as a upon under root of h square plus k square minus a square. Now we need this result in terms of tan alpha. Now we know that tan alpha is 2 tan alpha by 2 upon 1 minus tan square alpha by 2. So it will be this 2 a upon under root of h square plus k square minus a square upon 1 minus, and here will be this a square upon h square plus k square minus a square. Now we can write this as tan alpha, and here under root h square plus k square minus a square will cancel, so it will be this 2a into under root of h square plus k square minus a square upon, and here will be this h square plus k square minus 2a square. Now we square everything, we can write this as h square plus k square minus 2a square whole square into tan square alpha, and there will be 4a square h square plus k square minus a square. Now we'll replace h with x and k with y. So this required locus will be x square plus y square minus 2a square whole square into tan square alpha will be equal to 4a square x square plus y square minus a square, and which is what we need to prove in this question. Now the question is, a circle with center in the first quadrant is tangent to this line y equals x plus 10 and y equals x minus 6 and the y-axis. So we have coordinate axis, and then we have two parallel lines, and then it says we have this circle whose center is in the first quadrant and which touches these two straight lines and y-axis. Now suppose center of this circle be hk. Now we know that since this circle it touches y-axis, its radius will be equal to modulus value of its x coordinate. So equation of this circle will be x minus h square plus y minus k square, and it will be equal to h square. Now we find distance between these two lines. Distance between these two parallel lines will be given by 16 upon root 2, basically, which is 8 root 2, and this 8 root 2 will be equal to 2r, and r we know is mod h. So it will be this 2 mod h. So value of h is 4 root 2. Now we will find k. So this h, it is also its radius, which is 4 root 2. So perpendicular distance from center of the circle, it must be equal to its radius for this line, and this line is x minus y minus 6 equals 0. So we can write this as mod of h minus k minus 6 upon root 2. It should be equal to 4 root 2. Now h is 4 root 2, so we can write k plus 6 minus 4 root 2 will be equal to 8, or k plus 6 minus 4 root 2, it is equal to plus or minus 8. So if we take this plus sign, we'll get this k as 2 plus 4 root 2, and if we take this minus sign, we'll get this k as minus 14 plus 4 root 2. And since this center, it lies in first quadrant, k has to be positive, so we'll accept this value of k. So value of k is 2 plus 4 root 2. Now it says we have to find the value of h plus k. So value of h plus k will be 4 root 2 plus 2 plus 4 root 2, which is 2 plus 8 root 2. Now they've expressed it as a plus b into under root a. So in this case, value of a is 2 and value of b is 8. Now we have to find value of a plus b. A plus b is simply 2 plus 8, 10, And that is the answer to this question. Now it says a circle is described to pass through the origin and to touch these lines x equals 1 and x plus y equals 2. Prove that the radius of the circle is root of this equation. So we have these two lines, x equal to 1 and then x plus y equals 2. And this circle, it touches these two lines and it passes through origin. So it will be in this circle. Let the equation be x square plus y square plus 2gx plus 2fy equals 0, since it passes through origin. So value of c must be 0. And center will be at minus g minus f, and its radius will be under root of g square plus f square. So this point is minus g minus f. And if we look at this distance will be mod of 1 plus g, and it will be equal to r, and perpendicular distance to this line also will be equal to r. So perpendicular distance to this other line will be minus g minus f minus 2 upon root 2. It is equal to r, or mod of g plus f plus 2. It is equal to root 2r. Now basically we have to decide about these mod signs. Now clearly this point, it lies on the left of x minus 1. So 1 plus g will be greater than 0. So from here we can write simply 1 plus g, it is equal to r. And if we look at this line, then we put origin. So 0 minus 2, it is minus 2 less than 0. And if we put minus g minus f, so it will be this minus g minus f minus 2 will also be less than 0, as they lie on the same side. So from here we can write g plus f plus 2 will be greater than 0. So from here we get g plus f plus 2 will be equal to root 2r. So from here we can say value of g is r minus 1, and if we put r minus 1 here, we'll get f as root 2 minus 1 into r minus 1. Now we'll put the value of g and f in this equation. So now we can write r square will be equal to g square, and g square is r minus 1 whole square plus f square, which is root 2 minus 1 r minus 1 whole square. When we square it, we can write r square equals r square plus 1 minus 2r, and here will be this root 2 minus 1 whole square into r square plus 1 minus 2 root 2 minus 1 into r. Now here r square and r square will cancel. We can write this as root 2 plus 1 whole square. So there will be 3 minus 2 root 2 r square, and then it will be minus 2 root 2r, minus 2r and plus 2r will cancel. There will be minus 2 root 2r and then plus 2 equals 0. So radius of this circle will be given by this quadratic equation, which is basically the same equation, 3 minus 2 root 2 t square minus 2 root 2 t plus 2 equals 0, which is what we need to prove in this question. Now it says find the condition that the 4 points in which these two circles are intercepted by straight lines ax plus by plus c equals 0 and a dash x plus b dash y plus c dash equals to 0 respectively lie on and the circle. Now we have this first circle and this first straight line. So we write equation of all the circles which pass through intersection of this circle and line will be given by s plus lambda l equals 0. So here will be this x square plus y square plus ax plus by plus C plus lambda AX plus BY plus capital C equals 0. We can also write this equation as x square plus y square, and this is A plus lambda AX plus B plus lambda capital BY plus C plus lambda capital C equals 0. And the same way, equation of all the circles which pass through intersection of this circle and this line will be given by S plus lambda dash L equals 0. So that equation will be x square plus y square plus A dash x plus B dash y plus C dash plus lambda dash A dash x plus B dash y plus C dash equals 0. Now we can rewrite this equation as x square plus y square plus A dash plus lambda dash A dash x plus B dash plus lambda dash B dash y and plus C dash plus lambda dash capital C dash equals 0. Now it says we have to find the circle which passes through all these 4 points. So basically there will be this one circle which will satisfy both the equation, and for that circle these two equations they'll be same, and these two equations they'll be same if A plus lambda A upon A dash plus lambda A dash will be equal to B plus lambda B upon B dash plus lambda dash B dash will be equal to C plus lambda C upon C dash plus lambda dash C dash, and this is equal to 1. Now from this first equation we can write lambda A minus lambda dash A dash plus A minus A dash equals 0. In the same way we can write lambda B minus lambda dash B dash plus B minus B dash equals 0, and here we'll have lambda C minus lambda dash C dash plus C minus C dash equals 0, which are basically 3 linear equations. Now such a circle is only possible if these 3 lines they are concurrent. So these 3 lines they must be concurrent, and they are concurrent if determinant of A1 B1 C1 A2 B2 C2 and A3 B3 C3 is 0. So from here we can write determinant A B C A dash B dash C dash A minus A dash B minus B dash and C minus C dash, it must be equal to 0, and that is the answer to this question. Now here the question is, a circle is tangent to the x and y axis in the first quadrant at the points P and Q. BC and AD are parallel tangents to the circle with slope -1 if the points A and B are on the y-axis while C and D are on the x-axis, and the area of figure ABCD is 900 root 2 square unit, then find the radius of this circle. We'll draw this circle. Now this circle, it touches both the axes at points P and Q. So this is P and this is Q, and suppose radius is R. So center of this circle will be at R comma R. Now it says there are 2 parallel lines with slope -1 which touches this circle. So we have 2 lines which are parallel and whose slope is -1, where the points A and B are on y-axis and C and D are on x-axis. So this is A, this is B, this is C, and this is D. And area of ABCD is 900 root 2. Now since slope is -1, this point is suppose A comma 0. So this point will be 0 comma A, and this is B comma 0, and here will be this 0, comma b. Equation of this line will be x plus y equals a, and this is x plus y equals b. Now this line, it lies in the middle of these two lines, so this line will be given by x plus y equals a plus b by 2, and center of this circle will lie on this line. So from here we can write this r, it must be equal to a plus b by 4. So we have this r, which is a plus b by 4. Now we can write area of this quadrilateral ABCD. Now this AD is root 2a and this BC is root 2b. So this area will be 1 by 2 and then root 2a plus root 2b into this perpendicular distance, which is nothing but 2r, and it is equal to 900 root 2. Now we can take root 2 common, so it will be this root 2 and this 2 and 2 will cancel, and we have a plus b. Now a plus b is nothing but 4r, so it will be this 4r into r, and there will be 900 root 2. Now this is 100 and this is 225. So value of r is basically 15. So radius of this circle is 15 units. Now we have this circle whose center is at 2, 2 and radius is also 2. So this circle, it touches both the axes. And it says this circle is inscribed in a triangle which has two of its sides along the coordinate axis. So we have this triangle which circumscribes this circle. Now this is 90. Now we have to find locus of circumcenter of this triangle. Now let this point be h comma k, and since it is circumcenter, it is midpoint of this line, say AB. So basically a by 2 is h. So this a is 2h comma 0 and b is 0 comma 2k. Now equation of this line will be x upon 2h plus y upon 2k, it is equal to 1. And this line, it is tangent to this circle with center at 2, 2 and radius 2 units. That means perpendicular distance from the center must be equal to its radius. Now perpendicular distance from the center will be simply 1 by h plus 1 by k minus 1 upon under root of 1 by 4h square plus 1 by 4k square, and it should be equal to its radius, which is 2 units. Now we can write this as h plus k minus hk upon, and here it will be under root of h square plus k square, and we can take this 2 here and it is equal to this 2, and we have this mod sign. Now this 2 and 2 will cancel. We can write this as h plus k minus hk will be equal to plus or minus under root of h square plus k square. So this required locus will be x plus y minus xy plus minus under root of x square plus y square equals 0. Now basically here we are looking for one value of k, not two values of k. If we look at, now we look at this equation, which is x upon 2h plus y upon 2k minus 1 equals 0. Then origin and 2, 2 they lie on the same side. So for origin this is less than 0, and for 2, 2 will be 1 upon h plus 1 upon k minus 1 will be less than 0. And if it is less than 0, then the only sign that we have here is this minus sign. So in that case, this equation will be x plus y minus xy plus under root of x square plus y square equals 0. That is, the value of k is simply 1. So in this case, value of k is 1 and not plus minus 1. Now here the question is, an isosceles right angle triangle whose sides are 1, 1, root 2 lies entirely in the first quadrant with the ends of hypotenuse on the coordinate axis. If it slides, prove that locus of its centroid is 3x minus y whole square plus x minus 3y whole square equals 32 by 9. First we'll draw this triangle. With sides 1, 1 and root 2. So this length is root 2, this is 1 and this is 1. Now suppose this angle is theta. So here it will be root 2 cos theta comma 0, and this point will be 0 comma root 2 sine theta. Now these two angles, they are 45 degrees and this is 90. Now coordinate of this point, it will be this length, which is root 2 cos theta minus this length, which is 1 cos theta plus pi 4. And its y coordinate will be 1 sin theta plus pi 4. So this point, say C, and these are A and B. The C will be root 2 cos theta minus, now this is cos theta minus sin theta by root 2, and here it will be sin theta plus cos theta by root 2. Now this is 2 cos theta. So coordinate of this point C will be cos theta plus sin theta by root 2 and sin theta plus cos theta by root 2. Now we have to find locus of its centroid. Now suppose this locus is this point P, alpha comma beta. Now alpha will be 0 plus root 2 cos theta plus cos theta plus sin theta by root 2 whole divided by 3, and that will be 3 cos theta plus sin theta upon 3 root 2. In the same way we can write beta, and that will be root 2 sin theta plus 0 plus cos theta plus sin theta by root 2 whole divided by 3, and that is cos theta plus 3 sin theta upon 3 root 2. What we'll do is we'll find cos theta and sin theta. So for cos theta, what we'll do is we'll multiply everything with 3 and then subtract second from first. So there'll be 3 alpha minus beta, and now here will be 9 cos theta minus cos theta. So there'll be 8 cos theta upon 3 root 2. In the same way, for sin theta, we'll multiply the second with 3 and then subtract first from it. So then it will be 3 beta minus alpha, and we can write this as 8 sin theta upon 3 root 2. Now we'll square and add them. We can write this as 3 alpha minus beta whole square plus 3 beta minus alpha whole square, and that will be 64 upon 18, and sin square theta plus cos square theta will be 1. Now this is 32 by 9. And in the end, we'll replace alpha with x and beta with y. So this required locus will be 3x minus y whole square plus 3y minus x whole square, and it is equal to 32 by 9, which is what we need to prove in this question. Now here the question is, find the equation of the circle which touches the two lines and this given circle and is contained in the given circle. Now basically this circle, it passes through origin, and these two lines, they are also pair of lines drawn from origin. So here we are looking for this circle which touches these two lines and also this given circle. Now we know that center of this circle will lie on angle bisector of these lines, and we know that equation of angle bisector is given by x square minus y square upon a minus b, and that will be equal to xy upon h. The equation of angle bisectors is x square minus y square equals to 0. That is either y equals x or y equals minus x. And since this circle, it lies in the first quadrant, so this angle bisector will be along y equals x. So this line is y equals x. Now let this point be h comma h, and center of this circle is at 4 comma 4. Now radius of this bigger circle is under root 16 plus 16, and that will be 4 root 2. So radius of this smaller circle will be this diameter, which is 8 root 2 minus h root 2. So there will be 8 minus h root 2. All we need to do is to find the value of h and r. Now suppose one of these lines, it is given by y equals mx, then perpendicular distance from the center will be equal to its radius. So then we can write this mh minus h upon under root of 1 plus m square will be equal to this r dash. What we'll do is we'll square it. We can write m minus 1 square into h square will be equal to r dash square into 1 plus m square, and here will be this m square plus 1 minus 2m into h square, and there will be r dash square plus r dash square m square. Now we can write this as h square minus r dash square m square minus 2h square m plus h square minus r dash square equals 0. Now we can change this pair of lines in slope form by taking y by x as n. Now this equation will be 7m square minus 18m plus 7 equals 0. Now both the equations, they represent the same pair of lines. That means h square minus r dash square by 7 is equal to, now this is minus 2h square upon minus 18. So there will be simply h square by 9, and this again is h square minus r dash square by 7. Now from here we can write 9h square minus 7h square. So there will be 2h square, and it will be equal to 9r dash square. So basically this h is 3r dash by root 2. Now we put the value of h here. So we can write r dash equals 8 root 2 minus root 2h, and minus root 2h is 3r dash. So value of r dash is 2 root 2, and value of h is 6. So center of this circle is at 6 comma 6, and its radius is 2 root 2. So equation of this circle will be x minus 6 square plus y minus 6 square, and that will be equal to 2 root 2 whole square, We can also write this as x square plus y square minus 12x minus 12y, and this is 72. 72 minus 8 is 64. So plus 64 equals 0. And that is the answer to this question. Now here the question is, let W1 and W2 denote the circles x square plus y square plus 10x minus 24y minus 87. So that's your W1. And then the second circle, which is W2. That says, let M be the smallest possible value of A, for which this line y equals ax, it contains the center of the circle that is externally tangent to W2 and internally tangent to W1. So basically we are talking about a circle which touches W1 internally and W2 externally, and whose center lie on this line y equals ax, and the smallest possible value of a is given as m. Now it says if m square is p upon q, then find the value of p plus q. Now for W1, center is at minus 5, 12, and its radius will be 25 plus 144 plus 87, and there will be 6, 256, which is 16. So center one is minus 5, 12, and radius is 16. And for this second circle, center is at 5, 12, and its radius will be 25 plus 144 minus 153. So there will be 169 minus 153, which is simply 4. And if we look at C1, C2, C1, C2 is simply 10. Now suppose center of this required circle is h, AH, and its radius is r. Now W1 and W, they touch each other internally. That means distance between their centers, which is under root of h plus 5 whole square plus AH minus 12 whole square, will be equal to R1 minus R2. So it will be 16 minus R. Now W2 and W, they are externally tangent. That means C1, C2 equals R1 plus R2. Now in this case, it will be this under root of h minus 5 whole square plus AH minus 12 whole square, and they'll be equal to 4 plus R. Now we'll add them. So this R will get eliminated. So now we can write this as under root of h plus 5 plus AH minus 12 whole square plus under root of h minus 5 plus AH minus 12 whole square, and they'll be equal to 20. Now this is center of the circle C1, and this is center of the circle C2, and this center is C. Now if you look at this equation, then this is CC1 plus CC2, it is equal to 20. So that means this point C will lie on an ellipse whose foci are at plus minus 5, 12, and this is equal to 2a, and we use capital A, so 2a equals 20, and distance between centers, which is 10, it is 2ae, so 2ae is 10. So from here we'll get the value of e as 1 by 2 and value of a as 10, and b square is a square into 1 minus e square, and that will be 100, 1 minus 1 by 4, and that should be 75. So we have this ellipse with focus at minus 5, 12 and plus 5, 12. So its center will be at 0, 12. So it will be this ellipse whose equation is x square upon 100 plus y minus 12 whole square upon 75, and it is equal to 1. Now we have to find a point on this ellipse so that line joining the point to origin has the least slope. So we'll have to find this point where this line will be tangent to this ellipse. So we have to find this slope. Now we can write equation of tangent to this ellipse. So it will be y minus 12 mx plus minus under root of a square m square. So there will be 100 m square plus 75, and we want this tangent which passes through 0, 0. So we'll put x is 0 and y is 0. So there will be minus 12 equals plus minus under root of 100 m square plus 75. Now we square it, we can write 144 equals 100 m square plus 75, or 100 m square equals 69. So value of m square is 69 by 100. So we'll get the least value of a, which is m, such that m square is 69 by 100. Now it says this m square is p by q. We have to find the value of p plus q. And in this case, value of p plus q, it is 169. So answer to this question is value of p plus q is 169. Now here the question is, find the equation of the circle which passes through origin, meets the x-axis orthogonally, and cuts this circle at an angle of 45 degrees. So we have this circle which passes through origin and meets the x-axis orthogonally. That means x-axis is going to be normal. So center of this circle lie on x-axis, that's origin, and it intersects this other circle x square plus y square is equal to a square at 45 degrees. So this circle x square plus y square equals to a square at an angle of 45 degrees. Now suppose the point of intersection is x1, y1, and let equation of this circle be x square plus y square plus 2gx equals 0, where center of the circle is at minus g comma 0. Now we find the point of intersection, we can write x square plus y square equals a square. That means x1 will be minus a square upon 2g, and if we put x1 in this equation, we can write y1 square as a square minus a to the power 4 upon 4 g square. So we'll have y1 as plus minus a under root of 1 minus a square upon 4 g square. Now we'll find slope of the tangents for two curve. Now here we'll get 2x plus 2y y dash equals 0. That means m1 is minus x1 upon y1, and for this one we'll get 2x plus 2y y dash plus 2g equals 0. So we'll get m2 as minus g plus x1 upon y1. Now we can write tan theta, so there'll be this tan 45 m1 minus m2, so there'll be minus x1 upon y1 plus g plus x1 upon y1 upon 1 plus m1 m2, so there'll be x1 g plus x1 upon y1 square, and it is equal to 1. Now here x1 y1 will cancel, so we can write this as mod of g y1 will be equal to x1 square plus y1 square plus gx1 with a mod sign. Now we know that x1 square plus y1 square plus 2gx1 equals 0. So from here we'll get x1 square plus y1 square plus gx1, it is equal to minus gx1. So they'll be equal to minus mod of gx1. Now this g and g will cancel. If we square it, we can write y1 square is equal to x1 square. Now x1 square is a to the power 4 upon 4g square, and y1 square is a square minus a to the power 4 upon 4g square. So from here we can write a to the power 4 upon 2g square is equal to a square. Now this a square will cancel. So value of g will be plus minus a by root 2. And once we have g, we can write equation of this circle. So equation of this circle will be x square plus y square plus 2, and g is plus minus a by root 2x equals 0, or x square plus y square plus minus root 2ax equals 0. And that is the answer to this question. Now the question is, ends AB of a fixed straight line of length A and ends A dash B dash of another fixed straight line of length B slide upon axis of x and axis of y, one end on x and other end on y. Find the locus of the center of circle passing through AB, A dash and B dash. So we'll draw the axis and then we'll have this circle. Now one of the rod is AB and another one is A dash, B dash. Now length of AB is A and length of A dash, B dash is B. We have to find locus of center of this circle. Now suppose this angle is alpha and this angle is beta. So we can write coordinate of this point B as A cos alpha comma 0, and coordinate of A will then be 0 comma A sin alpha, and here this B dash will be B cos beta comma 0, and this A dash will be 0 comma B sin beta. Now we have to find locus of center of this circle. Now suppose this is H comma K. Now basically H is midpoint of B dash and K is midpoint of A dash. So we can write H as A cos alpha plus B cos beta by 2, and this K will be A sin alpha plus B sin beta by 2. Now here we have to eliminate alpha and beta. And here we have one more thing to our help, and that is these 4 points A, B, A dash, B dash, they are concyclic. And if they are concyclic, then OA into OA dash must be equal to OB into OB dash. That is AB sin alpha sin beta must be equal to AB cos alpha cos beta. That means tan alpha tan beta, it must be 1. That means alpha plus beta, it must be pi by 2. So we can write beta as pi by 2 minus alpha. So this H will be A cos alpha plus B sin alpha by 2, and here it will be A sin alpha plus B cos alpha by 2. Now here we have to eliminate alpha. So what we'll do is, from this equation we'll find cos alpha and sin alpha. So we'll write A cos alpha plus B sin alpha, it is equal to 2H, and A sin alpha plus b cos alpha, it is equal to 2k. Now we'll multiply this first equation with a and second equation with b and subtract. So we'll get a square minus b square cos alpha will be 2ah minus bk, or simply cos alpha is 2 times ah minus bk upon a square minus b square. And the same way we can find sin alpha. So there will be b square minus a square sin alpha will be 2bh minus ak, or sin alpha will be 2bh minus ak upon b square minus a square. Now we have to eliminate alpha, so what we'll do is we'll square and add. Now cos square theta plus sin square theta is 1. So then it will be this 4 ah minus bk square plus 4 bh minus ak whole square will be equal to a square minus b square. Now we'll replace h with x and k with y. So it will be this 2ax minus 2by whole square plus 2bx minus 2ay whole square, and that will be equal to a square minus b square whole square. Now here the question is, the angle between pair of tangents drawn from the point to this circle is 2 alpha. Find the equation of locus of point P. Now center of this circle is at minus 2, 3 and its radius is 4 plus 9 minus 9 sin square alpha minus 13 cos square alpha. Now 9 minus 9 sin square alpha is 9 cos square alpha. 9 cos square alpha minus 13 cos square alpha is 4 cos square alpha. So there will be under root of 4 minus 4 cos square alpha, and will be this 2 mod sin alpha. Now it says angle between pair of tangents drawn from this point to this circle is 2 alpha. So we have this point P, and from this point P we have drawn 2 tangents, and here this angle is 2 alpha. So this angle will be alpha. Now the center is minus 2, 3, and we have to find locus of this point P. So let this point be h, k, and this radius is 2 sin alpha. Now if this is 2 sin alpha and this angle is alpha, basically that means this distance is 2. So distance between center and this point, it is always constant. So its locus is a circle. So its locus will be a circle which is given by h plus 2 whole square, k minus 3 whole square, and it is equal to 2 square. Now we'll replace h with x and k with y. So it will be x plus 2 square plus y minus 3 square equals 4, or we can write x square plus y square plus 4x minus 6y plus 9 equals 0. And that's your option D. Now here the question is, find the intervals of values of a for which this line y plus x equals 0 bisects the 2 chords drawn from this point to this circle. So we have this circle which is 2x square plus 2y square minus 1 plus root 2ax minus 1 minus root 2a, y equals 0, and then we have this point on this circle from which 2 chords can be drawn, and this point is 1 plus root 2a by 2 and 1 minus root 2a by 2. And if we put it in this equation, it will satisfy this equation. Now it is given that this line x plus y equals 0, it bisects two chords drawn from this point. So what we'll do is, we'll take this point as, suppose, h comma k, and we'll find its midpoint. Its midpoint is, say, m. So its midpoint will be h plus 1 plus root 2a by 2 upon 2 and k plus 1 minus root 2a upon 2 by 2. And this point m, it will lie on this line x plus y equals 0. So we can write h plus 1 plus root 2a by 2 plus k plus 1 minus root 2a by 2 upon 2 will be equal to 0. Now this root 2a will cancel. So we get this value as h plus k plus 1 equals 0. Now from here we can write this k as minus h plus 1. Now basically h and k, they'll lie on this circle. So we can write 2h square plus 2k square, and k square will be h plus 1 square minus 1 plus root 2a h and minus 1 minus root 2a, and k is this value. So it will be minus minus plus h plus 1 and it will be equal to 0, which is basically a quadratic equation in h. Now since we need two chords, that means this equation should have two real roots, and for which this d, it must be greater than 0. So first we'll simplify this equation. You want to write this as 2h square plus 2h square plus 2 plus 4h, and then it will be this minus 1 minus root 2h and 1 minus root 2h. So there will be minus 2 root 2 ah and plus 1 minus root 2a equals 0. So this is 4h square plus 2 root 2 root 2 minus ah plus 3 minus root 2a equals 0. So that is the quadratic equation in h. Now if we take d greater than 0, we can write 8 into root 2 minus a whole square minus 4 into 4 into 3 minus root 2a greater than 0. Now this 8 will cancel. So we'll have this 2 here. So it will be this 2 plus a square minus 2 root 2a minus 6 plus 2 root 2a, and it will be greater than 0. Now this 2 root 2a will cancel. So we'll get a square minus 4 is greater than 0. Now this is minus 2 and plus 2. So this is plus, minus and plus. We'll need plus. So either a is less than minus 2 or a is greater than 2. So two such chords are only possible if either a is less than minus 2 or a is greater than plus 2.